BFS and call stack hurts my brain. We can easily solve this problem with the help of BFS iterative solutions. Hello everyone, let's solve some Leetcode today. So today we have Leetcode 104, that is maximum depth of binary tree. In this problem we have been given the root of a binary tree and we have to return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from root node down to the farthest leaf. It simply means that if we start from the root node, which of these leaf node is actually the farthest node from the root? We can see we have this node and this node which are farthest from the root nodes. So either this length or you can consider this length to be the depth of the tree because both of them are actually at the same level. So the most common way to solve this particular problem is simple DFS, that is depth first search. What you do is simply go to each and every branch once and go through those branches and then just count how many nodes you encountered, and from all these particular paths you can say which one is the longest path and you simply return the length of that path. But it requires you to understand recursion and call stack concepts, and these concepts really hurt the brain of beginners. So we can easily solve this problem by another method, that is BFS. This is an iterative solution. It does not have any call stack or recursion. BFS algorithm actually travels the entire tree level by level. This is first level, then we have this second level, and we have this third level. So you can see that the depth of the tree is simply the number of levels that we have in the tree. So we will go through all the levels and we will simply at the end of the day return how many levels we traveled through BFS, and that will be our answer. So let us understand concept wise how the BFS really works. First of all, we will have a queue in which we will put the nodes. First we are going to traverse through the first level, so I will simply in the starting take this node and put it here. Now we will have a while loop in which we are checking whether the queue is empty or not. If it is not empty, we will continue this while loop. So in the while loop, first of all, I will take the length of the queue because this length will tell me how many nodes are actually present on the current level that I am trying to traverse. So I am trying to traverse this particular first level and I have placed this node in the queue. So first I need to take the length. So here we are storing the number of nodes on the current level by taking the length of the queue at this particular instance of time. So we have only this particular node, so we get a length of 1. Now I will iterate over these current level nodes with the help of a for loop. So we are iterating over the current level nodes and then I will start popping the elements from the queue from starting. So once we have popped the element, we know that the 3 is gone from this queue. We can cross it. Now the queue is empty. So it means we have traversed this particular level completely. Now we do have to traverse the next level. So we will have to place these nodes in the queue somehow. So we can simply append these nodes in the queue. So here I am adding the left child and then the right child in the queue. So this queue will now become 9, then 20. Now this particular for loop is now done because this particular thing was equal to 1. So we will exit this for loop from here. Then we will come back here. We will check if the queue is empty or not. It is still not empty. So we will continue. Then we will take the current length. Then we know that the length is now 2. So this thing will simply become 2 now. Then we will start from 0 to 2. First we will pop this particular element 9. Then the children of 9 will be placed inside of it. So right now there is none. No children here. So we can put a check that will only append the elements in the queue if they are not none. Now since they are both none, we are not going to append anything and we will continue. The for loop will go to the next iteration, that is on this element. Now the 20 will be popped in this particular variable and we will have 20 here. Now we will add these elements in the queue on these lines. So we will have now 15 and 7. Now after that we will exit from the for loop. We will come back here. Then we will check if the queue is empty or not. It is not empty. We will again get the number of nodes on the current level. It will still be 2 because there are only 2 nodes in the queue now. And then we will again continue with this for loop. Now in this case they have only none nodes here. It means that nothing will be added in the queue and the queue will become empty after this iteration. So this loop will also exit after that and we have done our BFS traversal. How do we know how many levels we have traversed? So if you notice, this for loop is what helps us traverse the level. So after this for loop, we know that we have traversed one single level and we have appended the elements for the next level. So we can have a res variable here, that is our result variable, and it will be equal to 0. And after this for loop completes, we will simply say res is equals to res plus 1. We will simply update this variable by 1 once this entire for loop runs. And then at the end of the day, we will simply return res as answer. So the res variable will tell us how many levels we have traversed with the help of BFS, and the number of levels is basically the depth of the tree. Now let us go through the code also. Here we have res is equals to 0. It will be the answer that we are going to return. Here we have the queue initialized as empty queue. Now if we are checking if the root is none, it means that the input that we have is itself none. We can return 0 because there is no depth in a null tree. This is where we are setting up our BFS. We will add root into the queue and then we will start the while loop. While the queue is not empty, we will take the number of nodes on the current level and then we will iterate over each of these nodes. We will pop the element from the queue and then we will add its left and right child if they exist. Now once this for loop is done, we know that we have traversed through one level, so we will simply update this res variable here. Now after this entire while loop completes, we know that we have traversed all the levels, so we can simply return our res variable. Now let us run it and see what happens. So yes, everything is passing and it's a pretty efficient solution. Now let's talk about the time complexities of this particular solution. The time complexity for this solution is order of n. Even though we have nested loops, it is still order of n. Why? Because we are only going to traverse each and every node once. That's it. What this means is that the for loop and the while loop together will run at most n times only. So that's why it is order of n time complexity. In terms of space complexity, this solution is order of n too, because we are using a queue to store the node that we want to traverse later on. So the queue might actually store n nodes depending on the configuration of the graph. So yeah, like the video, subscribe the channel if you have enjoyed it, and if you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, then simply let me know in the comments. Now we will meet in the next video. Till then, bye.